Hello everybody, my name is Shishir and I am going to teach you the applications of finite automata in search engines. So here we begin. Introduction. Finite automata are a type of abstract machine that can be used to recognize patterns in text. They are simple machines, but they can be used to solve a variety of problems including string searching, patterns matching, and natural language processing. Their search engines use finite automata in a variety of ways to improve the accuracy and efficiency of their results. Some of the most common applications of finite automata in search engine include tokenization, query parsing, document indexing, and so much more. Ranking, ranking, spam detection, machine translation, personalization. In addition to these common applications, FA are also used in search engines for a variety of other tasks such as spelling correction, synonym expansion, entity recognition, question answering, etc. So we are going to talk about tokenization now. So search engines use finite automata to perform tokenization, the process of splitting text into smaller units called tokens. This makes uh, indexing and searching text more efficient and accurate. Finite automata can be used to identify specific patterns in text, such as words, numbers, and punctuation marks. For example, an finite automata can be used to split the query "What is the capital of France?" We all know it is Paris. In the token "What is the capital of" and France are the tokens. They are the tokens. FA can also be used to normalize tokens, such as converting all words to lowercase. This reduces the number of unique tokens that need to be indexed and searched, improving search performance. Overall, tokenization using FA is an essential part of search engine. So we are going to move next. Query parsing. It is the process of analyzing a search engine query to understand its intent and meaning. This is done by breaking the query down into component parts such as keywords, operators, and phrases. Finite automata are well suited for query parsing because they can be used to identify and match specific patterns in text. For example, and finite automata can be used to identify the keywords in a query such as cat and pictures in the query cat pictures. FAs can be used to identify operators such as and in the query cat and pictures. This information can then be used to execute the search query and return most relevant results. Here is an example how FA can be used to parse the query cat pictures. The FA would start by splitting the query into individual tokens cat pictures. The FA would then identify the keywords in the query cat pictures, pictures. The FA would then return the parsed query keywords such as cat pictures. This parsed query can then be used to execute the search and return the most relevant results. So next we have document indexing. So we can see here a flow chart. See tokenizing the title of news. We'll see when we get this example. Document indexing is the process of creating a searchable representation of text document. This is done by identifying and extracting the important terms from the document and then storing those terms in an index. Finite automata can be used to support document indexing in a number of ways. One way for one way to use FA for document indexing is to identify the tokens in a document. This can be done by using an FA to scan the document for specific patterns such as words, numbers, and punctuation marks. Once the tokens have been identified, they can be extracted from the document and stored in the index. Another way to use FA for document indexing is to normalize the tokens. This can be done by using FA to convert the tokens in to a common format such as lowercase. This makes it easier to search for documents and contain the same token, even if the token is written in different ways. Finally, FA can be used to remove stop words from the index. Stop words are common words that are not very informative, such as the and of. Removing stop words from the index can make the index smaller and faster to search. So our next title is ranking. Ranking is the process of ordering search results based on their relevance to the user's query. Finite automata can be used to support ranking in a number of ways. One way to use FA for ranking is to identify the named entities in a document named entities in a document. Named entities are people, places, organizations, and other important concepts that are mentioned in the document. FA can be used to identify the named entities by scanning the document for specific patterns such as capital letters and acronyms. Another way to use FA for ranking is to identify the semantic similarity between the documents. Semantic similarity is a measure of how similar the meaning of two documents is. FA can be used to identify semantic similarity by comparing the tokens in the two documents. If the two documents contain many of the same tokens, then they are likely to be semantically similar. This information can then be used to assign a higher rank to documents and that are more semantically similar to the user's query. Now we go to our next slide, that is spam detection. Spam detection. FA can be used for spam detection in search engines by identifying patterns in text that are common to spam. For example, excessive use of keywords. Spam often contains an excessive number of keywords which are repeated through the text. FA can be used to identify this pattern by scanning the text for sequence of keywords. Similarly, it can also be used for unusual capitalization and then phishing links. Once these patterns have been identified, FA can be used to assign spam score to each document. Documents with a high spam score can then be flagged or manual review or filtered out of the search results. By using FA detect spam. FA to detect spam, search engines can provide users with a cleaner and more relevant search experience. Then we have another slide. Machine translation. Finite automata can be used for machine translation in search engines by identifying and matching patterns in text. For example, FA can be used to identify the following: word boundaries. FA can be used to identify the boundaries between words in a sentence. This is important for machine translation because it allows the system to determine how to translate each word individually. And similarly, it will be used FA will be used to identify parts of speech of each word in a sentence, such as nouns, verbs, and adjectives. Then, similarly, it will be used to identify phrases in a sentence, such as idioms and collocations. Once these patterns have been identified, FA can be used to translate the text from one language to another. This is done by matching the patterns in the input text to patterns in the target language. For example, an FA based machine translation system might translate the English sentence I love you to the Spanish sentence te amo by matching the patterns I love and te amo. Now, personalization. Finite automata can also be used for personalization in search engines by tracking the user behavior and preferences. For example, search history. FA can be used to track the search queries that a user has entered in the past. This information can be used to personalize the search results by returning results that are more likely to be relevant to the user's interest. Click through rate CTR. FA can be used to track and which search results a user clicks on. This information can be used to personalize the search results by ranking higher the results that the user is more likely to click on. Similarly, dwell time. FA can be used to track how long a user how long a time a user spends on a particular search result page. This information can be used to personalize the results by ranking higher the result that the user is more likely to find useful. For example, once this information has been collected, FA can be used to create a personalized user profile for each user. This user profile can then be used to tailor the search results to the individual user's interest and needs. For example, a search engine might use FA to personalize the search results for a user who has a history of searching information about cats. When the user searches for pets, the search engine might rank higher results that are related to cats, such as cat breeds and cat food. This was all about personalization, and now we will go for spelling correction. If finite automata can be used for spelling correction in search engines by identifying and correcting common misspellings. For example, FA can be used to correct the following typos. Typos are the errors a user can make while typing. FA can be used to identify and correct typos such as te instead of the. Phonetic errors. FA can be used to identify and correct phonetic errors such as write right instead of write right. Real word errors. FA can be used to identify the correct word errors such as either THERE instead of THEIR or THEIR instead of THERE. Once the misspellings have been identified, FA can be used to suggest corrections. This is done by generating a list of candidate words that are similar to the misspelled words. The candidate words are then ranked based on their likelihood of being the correct spelling. The most likely candidate word is then suggested to the user. Now we'll go to the next slide. Synonym expansion. Finite automata can be used for synonym expansion in search engines by identifying and expanding synonyms of the keywords in a search query. This can be done by using FA to scan the document for patterns that are common to synonyms. For example, FA can be used to identify the following: related nouns. FA can be used to identify nouns that are related to each other. For example, automata might call identify that car and automobile are related nouns. Similarly, it will identify related adverbs, verbs, adjectives, and so once the synonyms have been identified, finite automata can be used to expand the search query to include the synonyms. This can be done by replacing the keywords in the search query with the synonyms. For example, an FA based synonym expansion system might expand the search query car rental to the search query car rental or automobile rental. By using FA for synonym expansion, search engine can help users to find more relevant search results even if they do not use exact keywords that are contained in the document. We'll go to the next slide now. Entity recognition. Finite automata can be used for entity recognition in search engines by identifying and extracting name entities from text. Name entities are people, places, organizations, and other important concepts that are mentioned in the text. FA can be used to identify named entities by scanning the text for patterns that are common to named entity, for example, capital letters. FA can be used to identify named entities that are written with capital. For example, finite automata might identify New York City is a named entity because capital N E Y E W, capital Y O R K, and then capital C I T Y is a named entity. Date and time, similarly. Numbers, acronyms. FA can be used to identify acronyms such as capital USA and capital WWW. Once the named entities have been identified, FA can be used to extract them from the text. This can be done by removing the surrounding text and leaving only the named entity. For example, finite automata might extract the named entity New York City from the sentence I visited New York City last summer. Now we'll move to the next slide. Question answering. Question answering is a challenging task that requires the ability to understand the meaning of a question. And to identify the relevant information in a text corpus. FA can be used in QA to perform tasks such as identifying the key concepts in a question. FA can be used to scan a question for patterns that are common to specific concepts. For example, FA can be used to identify the subject and predicate of a question as well as named entities matching the key concepts to the content of documents. FA can be used to scan the documents in a text corpus for patterns of match that the key concepts in the question. This allows FA to identify documents that are most likely to contain the answer to the question. Extracting the answer to the question from a document. FA can be used to extract the answer to a question from a document by identifying the sentences that are most likely to contain the answer. By using FA to perform these tasks, QA systems can provide users with more relevant and informative answers to their questions. These are all the extra These are all the extra tasks that can be done by finite automata in search engines, such as relevance feedback, click prediction, log analysis. And it is written here, search engines use FA to collect relevance feedback from the users. The relevance feedback is information that users provide to the about the relevance of search results. Search engines use FA to process relevance feedback and to improve the accuracy of the ranking algorithm. And click prediction, it is given here that search engines use FA to predict which results users are most likely to click on. Click prediction algorithms use FA to model the user's click history and the features of the search engines search results to predict which results are the users is most likely to click on. The log analysis is where search engines use FA to analyze their logs to identify trends and patterns in user behavior. Log analysis algorithms use FA to extract useful information from the logs and such as the most popular queries and the most clicked on results. The future of FA in search engine. FA are a tool powerful tool that will continue to improve their accuracy and their efficiency of search results in the future. FA can be used to develop more complex query parsing, more accurate ranking, the more personalized auto search algorithms. This will allow search engines to provide users with the most relevant and engaging search experience possible. Conclusion: FA are a powerful tool that is used in a variety of ways in search engines. FA are essential for many search engine tasks such as tokenization, query parsing that we discussed, document indexing we discussed, ranking, and spam detection we all discussed. FA are also used for a variety of other tasks such as relevance feedback, click prediction, and log analysis that we did discuss. As search engines become more complex and sophisticated, FA will continue to play an important role in improving the accuracy and efficiency of search results. FA are expected to be used to develop more complex query parsing algorithms and more accurate ranking algorithms and more personalized search algorithms. So I'll be thanking you now, and it was a great pleasure. Thank you.